Hello everyone, my name is Samuel Avrahami. I am part of Group 7 presenting the project of Eye for the Blind. My teammates are Caesar, Tristan, and Caleb. The problem our team is trying to solve is to implement a system where we can help people who are visually impaired. People who are not visually impaired, they don't really need to rely on a method to navigate themselves in the environment. The reason being is because they have their visual senses. However, that is not the same for people who are visually impaired. They need to rely on a method to navigate themselves in the environment. Some of these methods that are currently out there, they can be challenging for them and it may not be the best idea for them to use. For example, the cane. Most people who are visually impaired, they decide to use a white cane. This white cane may seem as a good idea, however, there can be a problem with it. The way there can be a problem is as the user is using the cane, it could sometimes get cracked by the pavement or get damaged by the pavement. And that could be very bothersome to the user of the cane and they may not want that. Another example is using a guided dog. Again, this may sound like a great idea. However, there's one big problem. After doing some research, I found out that a guided dog costs between $40,000 to $50,000. And that is a lot of money which a person who is visually impaired may not want to use. So we were trying to find a different method for them to use where it could be much more beneficial. The solution to this problem is to create a system that will act as eyes for those who are visually impaired. This would be done by creating a system with a microprocessor that would have many different types of sensors. And this device, it would be able to detect objects from a certain type of distance and warn the user in a few different ways. One way is by a sound, another would be through a voice, which would be done through Google Voice, and another option would be through vibration, where if the user didn't want to have any sound, he could have the option to have a vibration. What's also really interesting about this system would be depending how far the user is from the object, it will also be the same of how loud the sound will be or how sensitive the vibration would be. For example, if the user is very far from a distance, the sound won't be very loud. Similarly with the vibration, it wouldn't be as loud also. However, if the user is very close to an object, the sound would be much louder and the vibration would be much more sensitive. What's also really interesting about this system is that it would be much more different, as I mentioned earlier, of a guided dog or a white cane. With a guided dog or a white cane, all of that it does is to help the user to be able to know if there's certain objects in their way. However, with our system, the user would be able to tell the weather with the humidity subsystem. With this system, the user, he would be able to know what the weather would be like, and the user would be notified through Google Voice. And this is something which is really amazing because someone who is visually impaired may not be able to see what the weather is like. However, with our humidity subsystem, our user would be able to know what the weather is and be able to take precautions from that step on forward.
Hi everyone, my name is Cesar Nowakowski with Group 7. Today I'll be going over the system block diagram for our project that will be carried through ED2. My main goal here today is just to explain a little bit the type of sensors that we're using and how is the system gonna interact with the user. Now we can see in this block diagram that we have in this page that it's a very straightforward circuit. It's a very straightforward system. There's not much complication to it. And I just need you guys to keep in mind that a lot of those sensors, not a lot of them, but one for sure is the ultrasonic sensor. That is, we're looking to better options. So for the time being, that's the one that we're going with. I'm gonna go to the next slide and show a little bit of our intentions with this system. So our end goal with this project is to assist the vision impaired. And the way we thought that the approach that we had to do that is with integration of sensors into the user, like some equipment that the user can be wearing, and that will interact with him or her, with the user, and will give them information of their surroundings. So we have the ultrasonic sensor, and that one is to determine the distance. A ultrasonic wave is sent, and depending on the time that it comes back, it gives the distance. It converts that to a distance. So it's based to detect the objects and the surrounding of the user. We're gonna use a humidity sensor as well, and that's just for a better user experience. Just in case the user needs to know the temperature and stuff like that, the system will be able to notify him. And here we have the gyroscope. The gyroscope, in reality, the circuit that I have there on the side in the picture is a gyroscope, accelerometer, temperature sensor, and those are all built in already. In order to get fall detection, we need the accelerometer in combination with the gyroscope. So that's the one that so far we're going for. With the exception of the ultrasonic sensor, we're gonna look into better options than that one. Going to the next slide, this is the way that we decided would be best for us to interact with the user. One of them is the vibration motor, and the other one is the Google Voice. By implementing the Google Voice, the user will have a much better experience with the system itself. As the information is processed, the Google Voice can let the user know a certain distance from objects, from steps, and everything that is out there that the user needs to be aware of. The Google Voice will interact with the Google Voice will notify the user of their surroundings. Let's go to the next one just to resume. Over here, I came back to the system block diagram to show that the Google Voice and the vibration motor on the top, and they go to the user. And also the user has inputs, so you can decide to either use the Google Voice or not use it, the vibration motor. The initial idea was just the vibration motor, and would intensify depending on distance, but then that would be too complicated for the user to memorize and not understand, but to memorize the intentions of the vibration, to know for sure what distance they are from a wall per se. So we decided to go with the Google Voice, and that would be better. For the fall detection, we're gonna have a user input as well, because it might be just a small fall, nothing serious, so the user can stop the system from sending a notification to emergency contacts or to the police or anything like that. So the user will be able to cancel that. But if the user is unresponsive or is injured, if the user has a condition to say that it's injured, the system will contact the police or emergency contact. But if the user is grave shape, like bad shape, then the user doesn't have to do anything. You have some time there that the system will do everything on its own. So like I said, in order for the system not to do anything, the user would have to let the system know that it's okay, that nothing happened, nothing serious really happened. And that is it. Like I said, it's a super straightforward system. It's very simple, very basic. I'm gonna try to implement more stuff into it as we get over there, and that'll be it for today. Thank you.
Good afternoon. My name is Caleb Bieneme. I'm part of Group 7, and the title of our project is Eye for the Blind. And in this part of the PowerPoint, we're going to be speaking about the components that we have decided to use for our project. Here you can see that we have a couple of components that are listed: the ultrasonic sensor, the vibration motor, a gyroscope, temperature sensor, and then the main hardware part, the Arduino board. These are just a couple of the sensors that we have decided to use for our project, and we will implement more as we go along. But these are the four main ones that the professor has told us that we have to use. And then in the next slide, we're going to talk about the importance of each one. In this slide, we will be talking about the justification of each component that we have decided to use. The first component that we discussed was the ultrasonic sensor. This sensor will be used to notify the user of the distance of certain objects. For example, while the user, the blind person, is wearing this device, the ultrasonic sensor will be able to tell the user how far someone is approaching, or how far, if they're going to run into an obstacle, or if someone is coming up to them. Next component that we would need is the vibration motor. This will warn the user of oncoming danger or notifications. This will receive information from the ultrasonic sensor and warn the user if someone is approaching them by giving them a little vibration on their skin. This is a great idea, as many times when your phone vibrates, when you receive a notification, this is the same concept, as this will vibrate on the user's body and will be able to let them know that an incoming notification or danger or person is coming up to them. Now, the gyroscope is a GPS system where we will be able to place on the system for the use of a close friend to always have a monitor on the person, or the blind person, and will be able to watch and take care of them from far distance, and be able to see where they are and keep a tab on them. Now, a temperature sensor is able to tell the user the temperature at any given moment. This will help the blind person, as when they have left the house or so, the temperature sensor will be able to tell them if it's going to rain, or the temperature of the outside whenever they are. Now, the last component that we have is our Arduino board. This will be able to tie everything together, and we will also code this and be able to tie each sensor together, and sensors that we will add in the future.
Hello, my name is Tristan. I'm with Group 7, presenting the Eye for the Blind project presentation proposal. I wanted to go over a couple of things with you today, one of which includes the challenges in subsystem implementation. These are the things that we know about the device and the systems that we want to implement, and the things that we don't know. Starting with the known variables, the most simple and easy one is the distance that can be sensed by the ultrasonic sensor we're using. We know that from the datasheet that that sensor has. So we know exactly how far it will take for an object to be from that ultrasonic sensor before any input is read by the microprocessor, and subsequently how close the ultrasonic sensor can get to an object before it is no longer able to sense it. We also know the power consumption of the device in total based on all of the different sensors we're using, the datasheets that tell us their power consumption, and therefore how much power we need to supply to the device in order to keep it operational. The unknown variables include integration of Google Voice into the device. We want to have Google Voice as something that the device can use to audially tell the user that they're approaching too close to an object. In future implementations, and perhaps down the road, if we have a number of sensors placed across the user's body, then we can tell Google Voice to say that the user's right arm is close to something or their left arm is close to something. Additionally, programming of Google Voice to interface with the data acquired from the device, because we may be getting analog data rather than digital, it might be difficult for us to find the happy medium of analog data and values that the Google Voice can handle, and therefore give accurate feedback rather than random feedback if you've ever used analog devices before. Integration of the device into clothing. So we'd like to take the device itself and sew it into your clothing or the clothing of the user. So perhaps on a hat, on their shoes, on a glove, or a shirt. That way they can use it and not have to worry about something they have to put on, or even be able to throw it into the washing machine and not have to worry about the device getting destroyed on contact with water. The other and perhaps hardest to determine unknown variable is the environment in which the device will be used. So, for instance, it might make sense that the user needs to use this device while out and about on a street or a road or a sidewalk. But it might be more difficult to determine if the user will use it while going to work, such as in an office space where objects can come in certain intervals at various heights and at certain angles that are hard to determine from our bodies while walking. So for instance, a non-visually impaired person knows that the office cubicle wall is a certain height, but to a blind person or people with visual impairment, it might be difficult to determine how far away that wall is, or even if they could see the wall. Their vision might be so far gone that they can't determine where the wall is, how far away it is, or even how tall it is, or where the opening to get into the office cubicle would be. Additionally, other places include warehouses, complex situations such as street crossings or crowded city streets, or crowded environments for that matter, concerts and theaters where objects can be moving, which include people, or stationary such as seats at the theater. During our creation of the Eye for the Blind device, we're going to go through one, potentially several prototypes. However, at least the first prototype will include the most vital components related to sensing the environment around the user and communicating that data to them. So at minimum, the very first prototype we have will include the microprocessor base, the vibration motor subsystem, and the ultrasonic sensor subsystem. Without the ultrasonic, we can't see the environment around us, and without the vibration motor, at the very least, the user will never be able to know if that device is getting too close, and by extension, if they are getting too close to an object. The microprocessor base is also needed because without that we cannot analyze the data inputted from the ultrasonic sensor, and we will not be able to activate the vibration motor as the user gets closer to the object. The idea being that the closer to the object the user gets, the more the vibration goes, the higher frequency it goes, thus telling the user that they're getting closer to an object. Once the prototype displays good results from testing and we figured out all the sweet spots for analog readings, other subsystems can be added to the device, including the gyroscopic subsystem and the humidity subsystem, both of which are geared towards two specific demographics: the gyroscopic towards the elderly who may fall and need to get assistance in getting back up, and the humidity subsystem to those who are so visually impaired that they cannot see anything and may not know if rain is coming or other weather conditions that they might not wish to be in, such as if they were out upon the town and they don't want to get caught in the rain.
I created for our team a project timeline and schedule where you will start promptly on January 15th and follow from there on all of the required tasks that need to be finished. By the time we finish all of the tasks listed on here, we should be done by May 1st, which is required for us to our project to be given.
The last thing to talk about in this project presentation is the assigned tasks. Myself, Tristan Lehman, and Samuel Avharami will be doing the majority, if not all, of the software implementations. That includes the programming of the microprocessor, the Google Voice implementation into the device, and so forth. Additionally, Samuel will be assisting with documentation, especially related to software documentation, so programming languages we used, ways in which the classes interact, or any such things as that. I will be assisting in documentation, especially operation-related documentation, so how the device should be used, under what conditions it works, under what conditions it does not, and so forth. Caleb Bianami and Cesar Nowalski will be doing the assembly of the physical device. They are going to be wiring it up and making sure that everything fits together on the same board. They're also going to be in charge of documentation of the device and subsystem.